my name is Irene and I am an electronic engineering student in the UPM University. Today I'm going to talk about the mechanical structure and actuators in a robot, which is a basic part when designing a robot. First, what's the difference? Well, the difference is that the mechanical structure is the physical part that creates that movable skeleton, and the actuators are the ones that provide movement. I'm going to divide this presentation into 6 parts. First, system features, then kinematics and kinetics, mechanical structure, joint mechanisms, actuators, and robot performance. So, starting with the system features, there are mainly 2, the work envelope and the load capacity. The work envelope is the space in which the robot can operate, which includes the volume it occupies itself, plus all the range of movements that it can achieve. Then, the load capacity is the stress load of the man, the maximum stress load of the man that it can support. So, in other words, is the capacity of the robot to continue performing under hard conditions. These two system features, determine how is going to be the kinematic skeleton of the robot, which are 2 main types, Cartesian and revolute joint manipulators. The first ones are easy to program, but the second ones are more compact and efficient. Now, let's move on to kinematics and kinetics. What's the difference? Well, the difference is that the kinematics are the properties based on the geometry of the physical structure, and the kinetics are the properties based on the force applied. So, there are 2 main types of kinematic skeleton based on, well, a kinematic skeleton is made of a relays of links connected, forming a serial chain. If it's only one serial chain, it's called serial robot, and if it's a set of serial chains supporting one end effector, it's called parallel robot. Okay, now let's move on mechanical structure. Well, when we are modeling a robot, we pretend to make its movements dynamic. So to achieve this, we have to minimize the force applied on the links to cause the deflection, choosing the correct joint mechanisms. There are 2 main types of joint axis structure, which are the revolute and the prismatic joints. The revolute joints are made to achieve rotary motion, and their principal quality is stiffness. And the prismatic joints can be divided into single stage and telescoping. The single stage are made of a sliding surface that moves linearly, and the telescoping are made of a set of staked single stage joints. Now, the actuators. Well, there are mainly 3 types of actuators, which are the electromagnetic, the hydraulic, and the pneumatic. The first one, the electromagnetic, most used actuators are the electric servomotors, which are made to achieve certain positions, velocity, and torque with variations in frequency. Then, the hydraulic actuators are made to achieve large force and power with small inertia and can achieve linear and rotary motions, but they have a power supply. The power supply is very bulky, they are relatively expensive, and they have a lot of maintenance issues. Now the last one, the pneumatic actuators are simple to control, low in cost, safe, and less affected by ambient conditions, but they have a low energy efficiency. We also have to take into account the transmissions, which transfer energy from sources to load. There are a lot of drive mechanisms to choose, such as direct drives or gyres. Now we are going to move into the last sessions, which are the robot performance. Well, there are mainly 6 specifications to take into account that are speed and acceleration, repeatability, which is the ability of the manipulator to return repeatedly to the same place, resolution, which is the smallest incremental motion achieved by the manipulator, accuracy, which is the capacity of the end effector to place to a predetermined position, the component life, which are the time the component should work properly, and the crash resistance. You have to think about that collisions could occur. So, to finish these presentations, I'm going to do a summary. When we're designing a robot, we have to think about some things. First, the system features, which are the work envelope and the load capacity, then the type of robot, serial or parallel, the mechanical structure, the joint mechanism, revolute or prismatic, the actuators, electromagnetic, hydraulic or pneumatic, and finally the performance specifications of the robot.